Alright, we ready? Alright, so solving trig equations that involve quadratics. So the first type that we could see would be a term squared equal to a single value. Something plain and simple like this. So I want to know what x is. In this case, I'm solving for x. What do? Square root. Everybody knows that, right? So I'm going to take the square root of both sides. Be careful when you do this. What do I have to account for when I take the square root? Positive or negative. So that means that x is equal to positive 1 or negative 1. Two different solutions. Now think how that's going to make a difference if I'm solving a trigonometric equation that has a quadratic. So say that I have sine squared of theta is equal to 1. And we'll make it simple. I'm restricted on the unit circle. So I want to know all the values of theta that will make this true. So the way I would solve this equation is the same exact way that I would solve the basic algebraic quadratic. So I want to get sine all by itself before I can ever start looking at angles. How am I going to get rid of that square? Take the square root, just like I did with the x. And again, just like with just the x, I need to account for the plus or minus, right? So that means that sine of theta is equal to plus or minus 1. Now, working with the trig equation, I have one more step after that, right? So I'm going to break it apart into the two different equations I have. I have that sine of theta is equal to positive 1, and sine of theta is equal to negative 1. Now I have two basic trig equations to solve. So I have the trig equation, or the trig function by itself, and now I can go and look at the unit circle. When is sine equal to positive 1? Pi over 2, right? I'm restricted to the unit circle, so that's all I'm concerned with. It's the only place that happens is at pi over 2. So theta equals pi over 2. And so now I'm going to go on to the next equation. When is sine equal to negative 1? It's 3 pi over 2. Alright, it's the only typo on the chart. It's 3 pi over 2. If you look at the unit circle, it's 3 pi over 2. That's what you meant. That's what you said. That's what I heard. 3 pi over 2. Right? So at 3 pi over 2, sine is negative 1. And that's it. Those are my solutions to the equation. That's it. When we weren't restricted to an interval, right? I only want the values of theta that make this true on the unit circle. If that went away, these wouldn't be my only values, right? It would happen at pi over 2, and then 3 pi over 2, and then I'd loop back around the unit circle, and so it would happen again at 5 pi over 2, and then 7 pi over 2, and on, right? I would have several of them. And it would also happen at negative pi over 2, negative 3 pi over 2. And so instead of listing all of those out, that's why we use the k values. There's so many of them. Okay? But the difference here is we are restricted. Questions about that? All right, so let's look at type 2 then. X squared is equal to x. Now, a lot of people's instinct is to divide by x. Don't do it. Fight that instinct big time, okay? I want to get x all by itself. Now, in the first one, type 1, we just went ahead and took the square root. Well, that was fine because I had a number over here, and so I actually got a value. If I take the square root here, I'm going to get x equals plus or minus the square root of x. Is that helpful? No, I don't know what that means, right? So I need something to actually give me values. So anytime you have two single variables, right? I have two variables, or in a second we're going to look at two functions, two trig functions. If I have two variables, I need to get both variables on the same side of the equal sign. So I'm going to subtract x from both sides. I get x squared minus x equals 0. Right? And be careful with that. Are x squared and x like terms? No, that's why I didn't subtract them, right? X squared minus x is just x squared minus x. Now, I have them both on the same side, and I can factor them. What do x squared and x have in common? They have an x, so I'm going to pull that x out. So when I pull that x out, remember this is like the reverse of distributing. So instead of multiplying, I'm dividing. What is x squared divided by x? X minus, what is x divided by x? 1 equals 0. And now this is in factored form, and we've solved several quadratics in factored form. I have two things being multiplied together, and I know it has to equal to 0. If that is the case, what must be true about at least one of the things I'm multiplying together? It has to be equal to 0, right? It's the only way I can get 0, so I'm going to set them both equal to 0 to see what makes that true. The first one is already solved, x equals 0, so that's it. The second one, to get x all by itself, I'm going to add 1, so I get x is equal to positive 1. And those are my solutions. Alright, now the same thing relates to trig functions. So, let's say I have tangent squared of theta is equal to tangent of theta. And I'm not going to restrict it. No interval. Alright? No interval. I want every single value of theta in the world that would make this true. Alright? So, in the same exact way I solved the algebraic equation, I want to solve the trigonometric equation. So, I have two functions. I need to move them on the same side of the equal sign, factor out what they have in common. So I'm going to subtract tangent from both sides. So I get tangent squared of theta minus tangent of theta is equal to 0. Factor out what they have in common, so I'll pull tangent out. That leaves me with tangent minus 1 equals to 0. And now, I'll pause there. Is there questions about that? It just makes it look neater since I have other stuff that already has parentheses. Alright, so now that I have it in factored form, I can use the zero product property or whatever you want to call it. I know I'm multiplying two things together and it has to equal 0, so one of them has to equal 0. So I'll set them equal to 0 and see what makes that true. So I'll get tangent of theta equals to 0 and tangent of theta minus 1 equals to 0. Now I have two basic trig functions that we can solve. Remember that I'm not restricted to any interval. So the first equation, tangent of theta is equal to 0. I have my trig function all by itself, so I can go to my unit circle. What values of theta make tangent equal to 0? So 0, and then pi, and then 2 pi. What's the distance between all of those values? It's all pi, right? So how many answers do I actually need there? Just one, because they're all equidistant, right? Use a little geometry term there for you. Alright, so theta would be, and when I have multiple angles that have this property that are all equidistant, I'm going to take the smallest angle. So what was the smallest angle that made this true? 0. 0 was the smallest angle that made this true. So I'm going to do 0 plus, y'all want to work with degrees or radians? Degrees. Alright, so 0 plus what? 180, right? Remember that the period of tangent is 180, so I'm going to have 180. Okay. Can I simplify this one a little bit? Most of them you can't, but can I simplify this one? How? Just 180k, right? Why? I'm not going to say it's dumb, but it's unnecessary, right? The zero is unnecessary. So if you didn't rewrite it, if you left it as that, awesome, that's okay. If you wanted to be fancy and rewrite it as just 180k, then that's cool too, right? This is the smallest angle. If you look at your unit circle, it's the smallest angle where tangent is equal to 1. Where tangent is equal to 0. You find it? Yep, okay. So tangent of 0 is 0. It's the smallest angle that makes that true. So there we go. There's my first solution. So let's go to the second. I need to get the trig function all by itself. So I'm going to move the 1 to the right. I get tangent of theta is equal to positive 1. So now again, I have the trig function by itself. I can go look at the unit circle. For what values of theta will tangent be equal to 1? Pi over 4. 5 pi over 4. What's the distance from pi over 4 to 5 pi over 4? Pi, and then from 5 pi over 4 back to pi over 4? Pi, right there, equidistant. That's this situation going on right here, right? This is pi over 4, this is 5 pi over 4. The distance from the first to the second is pi. Distance from the second to the first is pi. So I only need that first one in my solution. So I'm going to have theta is equal to, where we said degrees, so let's be consistent. So theta is going to be equal to what? 45 degrees plus, we want to be consistent, so 180k, right? If we were working in radians, it would be pi, but we're working with degrees, so it'll be 180. And there we go. That's it. Yes, sir. So again, the value that we add is going to come from the period of the trig function that we're working with. I'm working with tangent. What is the period of tangent? Guys, what's the period of tangent? It's pi, which is 180 degrees. Right? If you go back to number 3 from our quiz that we took earlier, we were dealing with sines. The period of sine is 2 pi, which is 360 degrees. So in our solutions there, we added 360 instead of 180. Oh, okay. So dig back deep to when we talked about the period of the trig function. All right. So the last type that we could see is the general standard form of a quadratic, right? How do I solve this quadratic? So I'm going to factor it. I'm going to factor it, okay? Especially those is... All right. This is a quadratic, you're right. All right, so we are going to factor this. All right, we are going to factor this. So I do not have a value in front of x squared. So all I'm looking at is my constant. The number at the end, the number without a variable. So this positive 2. And I want to know, what are the factors of 2? 2 and 1. 1 and 2. However you want to write it, I don't care. Alright. This one's fairly simple because I only have one set of factors. What is 1 plus 2? 3, which is what I'm trying to achieve. I want the set of factors. I want the set of factors that will combine together, add together, and give me the center number, my middle value, my B, as you were talking about. So I know that if I do 1 times 2, I'll get 2, and if I do 1 plus 2, I'll get 3. So these are the values that I need. So when I break it apart into factored form, I'll have x plus 1 and x plus 2 equals 0. And again, we come up with that zero product property, whatever you want to call it. I have two things being multiplied together that give me 0. So that means at least one of them has to be 0. So I'll set them equal to 0 to see what makes it true and solve the equation. So I get x equals -1 and x equals -2. Yes. Don't do it. I'm postponing for months. Alright, so same exact thing if we were dealing with the trig function. Alright. In the last class, we looked at an equation that had squared things in it, but we didn't work it like a quadratic, right? We had something, I'm going to come over here to my scratch paper. We had something that looked like, I don't know, something crazy like that. Sine squared theta plus cosine theta minus 1 plus cosine squared theta equals 0. I have stuff in there that's squared. Why do I not work this like a quadratic? The Pythagorean identity, right? I have an identity that I can use first that will allow me to simplify this equation without getting crazy with it, right? What is sine squared plus cosine squared? 1. So I have cosine theta minus 1 plus 1 from my Pythagorean identity. -1 plus 1 is 0. So this all just fizzles down to cosine theta equals 0, right? So still be on the lookout for identities, because if you can simplify it beforehand, save yourself some time, do that. If that is not the case, though, let's say that I have alright, sine squared plus 3 sine plus 2 equals 0. This is a quadratic. I cannot use the Pythagorean identity to simplify this. I don't really see any other identity that I can simplify it, but it definitely is a 3-term quadratic. How do I solve this? I factor it, right? Same exact thing. Pretend you could even rewrite it with x's instead of sine if it made you feel better. But it works exactly the same way. I'm looking at the factors of the last number that multiply together, obviously 3 factors to give me that number, and then combine together, add together to give me my center number. What are these fancy numbers? 2 and 1. Exactly. So I would have sine theta plus 2 and sine of theta plus 1 is equal to 0, just like I had with the x's. Same exact thing, except I have sine. And I'll continue to solve it in the same exact manner. I have two things multiplied together that are equal to 0, so one of them must be equal to 0. Set it equal to 0 to see what makes that true. So I get sine of theta plus 2 equals 0, and sine of theta plus 1 is equal to 0. Two basic trig equations to solve. So starting with the first one, remember I have to get the trig equation by itself before I can go to my unit circle. So I get sine of theta is equal to -2. What values of theta make this true? None. Why not? All right. What is the smallest sine can be? What is it? -1. Right? Look like you're in a circle. Sine is what? X or Y? Y. It's my unit circle, right? What is the highest point? What is the highest point on the unit circle? Is that a point? Is that a coordinate? 0, comma 1. Sine being the y value, so the highest sine can be is 1. What is the lowest point on the unit circle? 0, -1. Again, sine being the y value, so the range of sine is -1 to 1. Anything outside of that interval, I will have no solution for it. No solution, right? Same thing with cosine. So sine theta equals -2. There is no such value. So I don't have a solution from this equation. Does that mean my overall equation doesn't have a solution? No. That just means that this little tidbit didn't give me anything, right? So he's useless, right? So now I'll come to the other equation. Again, get the trig function all by itself. So I have sine theta equals -1. I have the trig function by itself, so now I can go to the unit circle. When does this occur? 3 pi over 2. Am I restricted? No. So how often is this going to happen? Every 2 pi, right? Every 2 pi. So everybody's throwing out radians at me, so we'll just put in radians. So I'm going to get from this one over here, theta is equal to 3 pi over 2 plus 2 pi k. So that's every value ever that will make sine theta equal -1, and in turn make my quadratic equal to 0. So that is the solution to this quadratic.